Okay, let's turn to problem set 5, which is about a market entry strategy, but also about sensitivity analysis. So Heidi manages a firm that is going to start operating in a new market. She has the option of targeting either high-end consumers or low-end consumers. She has some uncertainty regarding actual market conditions in each of these two segments. Very loosely, she thinks that market conditions in each segment could be either favorable or unfavorable. The probability of favorable versus unfavorable conditions in each market segment, along with her resulting profit in each case, is given in this table. So A, draw the decision problem. Okay, let's create some space here. Okay, so she needs to target. So she needs to decide, shall I target the high end, and if I target the high end, then, or if Heidi, then Mother Nature decides whether the condition will be favorable and that will be with probability P, or the conditions are unfavorable, with probability 1 minus P, P. Okay, and she can also target the low end. And then again, Mother Nature will decide, or the state of nature, whether the condition will be favorable and this with probability Q, or unfavorable with probability 1 minus Q. Okay, so now we can also add the payoffs. So if things are favorable in the high-end market, she will make 800,000, otherwise 200,000. And in the low end, it's 500,000 and 400,000. Okay, so that's the decision tree. Okay, so next question. If the probability is 2/5, okay, let's add this one. So if the probability of favorable in the high-end market is 2/5, maybe let's put here 2/5, and 3/4 for Q. Well, that means that 1 minus Q is 1/4 and 1 minus P is 3/5. So for what range of Q should she serve the low-end consumers? Okay, so in this case we have to ask under which condition is serving the low-end consumers favorable. So let's create that here, which actually I should have. So we added a probability. Okay, so no, I'm sorry, which segment should she serve? I already looked at the next one. Okay, so now we just calculate the expected payoff for high end. Expected payoff, I just called it now high. And that is 2/5 times 800,000 plus 3/5 times 200,000 and that is equal to, so 800 divided by 5, that's 160, 2 times 160, 320, and then 200 divided by 5, that's 40 times 3, 120, so it is 320 plus 320 plus 120, so that should be 440. So 440,000. Okay, what's the expected payoff of low? Okay, so 3/4 times 500 plus 1/4 times 400 Okay, so this is 500 divided by 4, that's 125, times 3, 375, and this is 100, so this is 475,000. Okay, so then the decision is obviously to target low. Okay, so now let's do C. Suppose that the probability of favorable is 2/5. For what range of Q should she serve the low-end consumers? So in this case, Q is a variable, so let's remove the 3/4 again and the 1/4. And we want to know for what range of Q should she serve the low-end consumers. So the idea is to say under what condition is low-end better than high-end. So low is better than high. And for high, nothing has changed. So the expected payoff is still 440. So we need to find the condition when the expected payoff from low exceeds the 440. So that means we have to solve. So the expected payoff for the low end is 500,000 with probability Q plus the 400,000 with probability 1 minus Q well, that needs to be greater than the expected payoff from high when the probability is 2/5. so greater than 440. Okay, so now we can collect terms a little bit. So this is 500,000 Q, and then we have here minus 400,000 Q, so we are left with 100,000 Q. And then we have here the 400,000, but I already subtracted from the 440,000. So I'll jump over. So I subtract already the 400,000 times 1 on both sides. That leaves me off the right hand side with 40,000. And then it should be clear, as long as the probability of Q is greater than 40 over 100,000, which is greater than 0.4, we should always target the low end. Okay. But now we go back. Suppose that Q is 3/4. Okay, so let's put that back. So Q is 3/4. Then 1 minus Q is 1 over 4. For what range of P should she serve the low-end consumers? Okay. So now the probability of favorable is a variable. Okay, so now we want to know for what range of P should she serve the low-end consumers. Okay, so that means the P, the expected payoff from the high end should always be less than the expected payoff from the low end if Q is 3 over 4 and 1 over 4, and we know that this is 475. So that means we need to solve. So we need to solve that the expected payoff from high end, which is 800,000 times P, plus 200,000 with 1 minus P, okay, so this is the expected payoff from the high end, and then it should be always less than the expected payoff from serving the low end. So that is the expected payoff that you see here from high end, and it should be always less than the expected payoff from low end. And because the probabilities are the same, we can just take that value 475,000, which we already calculated earlier. Okay, so this is now what we need to solve. So, okay, so let's create a little bit of space. Okay, so this is what we need to solve. So now, again, we have here 800,000 P minus 200, so that leaves us with 600,000 P. And then I have here the 200,000, but I already subtract that on both sides. So I'm left here on the right hand side, we get 475,000 minus 200,000, which leaves us with 275,000. So now we know that as long as the probability of a favorable condition in the high-end market is less than 275 over 600, we can already, which is equal to 275 over 600, 275 divided by 600. Okay, so that's 11 over 24 or 4.583. So as long as the probability of 4.58. So as long as the probability of a favorable condition in the high-end market does not exceed 45.8%, serving the low end is favorable. Okay, so now Charlie claims if the probability of 1/2 for the the probability for a favorable condition in the high-end market, you should serve the high-end consumers regardless of the value of Q. And if the probability is less than 1/3, then you should serve the low-end consumers regardless of the value of Q. So derive a general condition in terms of both P and Q that Heidi can use to determine which market segment to serve. From this condition, verify that Charlie's advice is indeed correct. Okay, so let's say I want to establish the condition for high end always better. For high always better. So the condition for high always better. So that is 800 times P plus 200 times 1 minus P. That is the expected payoff from high. So as long as, and I'll just forget about the thousands now, because, yeah, actually I can do it just to be complete. So 800,000 times P plus 1 minus P times 200,000. That always needs to be greater than the 500,000 is probability Q, and the 400,000 is probability 1 minus Q. So that is the general condition. So 500,000 times Q plus 1 minus Q and times 400,000. So that's a general condition. So now we need to collect the terms a little bit. Okay, so I have here 800,000 P plus 200,000 minus 200,000 P. Okay, so here I get 600,000 P plus 200,000. Okay, so that is just rewriting the expected payoff for the high end differently. That needs to be greater than 500,000 Q, but then I subtract here 400,000 Q, so I'm left here with 100,000 Q. And then I still add here plus 400,000. 1 times 400,000. Okay, well, so now we have a lot of 100,000, so let's just divide everything by 100,000, and then we get 6P plus 2 needs to be greater than 1Q plus 4. And now maybe let's collect the terms on one side, and then we get let's get the variables to one side, so then we get 6P minus 1Q needs to be greater than 2. So that would be the condition, unless I made a mistake, but let's double check. So if P is greater than 1/2, so let's double check. We plug in for P 1/2. So let's do it this way. If P is equal to 1/2, then the condition is 6 times 1/2, that's 3, minus 1Q greater than 2. So we see, even if the probability of Q were 100%, then we get 3 minus 1, which is greater than 2. So indeed, as long as the probability of a favorable condition is greater than 1/2, you should always go for the high-end market. So what did Charlie say? If P is greater than 1/2, then you should serve the high end. This is correct. Okay, but if the probability of a favorable condition in the high-end market is less than 1/3, so now let's check. Let's do this one, see what happens if this is 1/3. So then we get 6 times 1/3, and we get 2. But then, even if the probability of Q would be would be 0, and we would get 0, so that means at any probability of P which is less than 1/3, that condition actually also holds. So if the probability is of a favorable condition in the high-end market is less than 1/3, if it were, let's say, 1/3, this becomes 2. And then, you know, just a little bit of a probability that something is favorable in the low-end market, like 0.001 for Q, that will now make the low-end consumers more attractive. So Charlie is indeed correct, and this here would be the condition. Okay, so that was another problem set on basically sensitivity analysis. And yeah, let's just stop here and then continue with another problem set. I will just erase this one still here. Okay, so I'll see you in the next video.